Okay, so which what do you call it? A company are you in now?
Same Navigate. I got my command last year and I did Aragonite, Navigate Aragonite.
Oh, okay. So you're still in Suntech? Navigate.
Yeah, Navigate.
Suntech.
Same. Yeah, still with them.
Okay. Okay, perfect. So first of all, I would like to congratulate you. The last time we met, you were still a maid.
Yeah, thank you. So if I could survive in Navigate as a maid, I think as a master, it will be manageable. So I'll stick here for a while.
Okay, that's good to hear.
So I'll just share the slide. For preparation for wall wash tank cleaning, I will not be talking about the how to do the tank cleaning for wall wash. That is, the different video someday. It is just about the how to do the wall wash testing on board without the spectrometer.
Okay.
About the spectrometer, I have no experience. You just share a little bit of spectrometer, how it is done, and what is the concept of spectrometer at the end of this conversation.
Sure, no problem.
What are the basic stuff? I'll just keep saying that you need to prepare all this wall wash equipments kit as per the list that you have on board, and make sure you keep it in a nice clean bucket and keep
that's right.
funnel in a nice plastic. Carry all your methanol markers, your gloves, and your shoe covers, and then you go into the tank and then do your wall wash testing on maximum bulkheads, whichever is possible, and make sure the bulkheads are dry and they do not contain any moisture or water droplets or any of the cargo particles.
Perfect. Yeah, that's right.
Okay, so far so good. All right. So once you're done with the sampling, you collect enough samples, probably half bottle, and then you close the cap properly, mark it which tank you have come, you have taken the sample, because it might happen that you might get confused between which tanks later on. So you just mark it properly. Then like Rex does, I have followed his style. He will again put all the funnel and everything back in his plastic and in his nice pouch. Then he will climb up. And now, assuming you guys know how to take the wall wash sample from the tank, now you have to go and do the wall wash testing in your laboratory or in your CCR or in your engine office, depending where you have set up.
Yeah, exactly.
So this is how the wash is being done. So we will just talk about the visual. So tell me about the visual. What do you look for in the visual standards?
For visual, actually, you have to, number one, check which is the immediate observation that you can get from your sample. So what is it? Number one is the color. So basically you have to compare your wall wash sample from the fresh solvent that you are using as medium for taking wall wash. So any deviation from the solvent, the fresh solvent, you can consider it like contaminated. So check also for particles or any suspended matters present.
Okay.
You have to also classify how the extent of the particles present. You may say it's a slight, moderate, or heavy, something like that. Yeah.
Okay. Sometimes there is very slight sedimentation at the bottom of the glass bottle when you shake it. So how much in your experience do you think it's acceptable?
Actually, there's no perfect wall wash sample that is free from suspended particles. You can really find some particles suspended on it, but up to what extent? As long as it's not like like a snow roaming, circling into your sample, I think that should be fine. Like a snowflakes circling around.
Okay.
Yeah.
So if you have major snowflakes kind of particles and paint flakes, then it will be a concern for the, for the this survey will actually test it. Okay. So basically, we want to keep our samples as clear as possible.
As clear as possible. That's right. That's right.
All right. And the next we go to the odor. So in the sample, you should have the same smell that you get from the reference sample from the methanol. You should have the same odor from the sample that you have collected from your tank. If you are able, if you're getting any other smell, that means you have a non-characteristics odor, I believe.
That's right.
All right. So that is the visual is covered and the odor. Basically, in the tank, whenever you're going inside the tank, you should not have any odor of any of previous cargo or any other cargo. It should be as clean as possible.
Yep. In odor tests, there are actually two different classifications in reporting. One is the MCO, or the methanol characteristic odor. The next one is the non-residual. So for MCO, basically you only have to compare the odor of the solvent from the reference. So it should have similar or the same odor. That is for the methanol characteristic odor, or MCO. But for the non-residual, you have to use additional material for you to enable to report if it's residual or non-residual odor. For instance, you have to use a strip of filter paper, maybe, dip it into your sample. Once you dip it, let it dry. Once it dried, you have to smell it. If it smells like a gasoline or whatever petrochemical smell, then you can say it has a residual odor. Otherwise, it should be non-residual, something like that.
Got it. So it should be non-residual.
Yeah, it should be non-residual. So you have to identify which reporting system you have to use.
Okay. So now we will come to the actual test wherein we involve the DI and other chemicals. So hydrocarbon. So basically in hydrocarbon, what we do is depending on the requirement from the load port, you will always get in advance how they are going to do the ratio. 1:9 or 2:8 or 25:75. The ratio will be mentioned before your tank cleaning. So accordingly, you know that is the ratio that you have to use your testing. But the strictest is 50-50, right?
That's right. The more sample, the more strict.
The more sample you have, the more stricter will be your test criteria. So in case if you're going for 50-50 and if you see there is no hydrocarbon in the sample, that means whenever you're going for your actual loading and he's going in a ratio of 25-75, that means for sure you will be passing your tanks.
That's right. Exactly. That's the safest way of doing things. Like normally in the load port, most ports, as I know, they use this ASTM 1722, which actually suggests to use 10% of the sample and 90% of DI water. So what we normally do on board is to check the hydrocarbon using a 25-75 dilution instead. So this way, this will keep us on the safer side. So there will be some certain margin. We wouldn't know because, as we all know, well wash is very random. One person can take a wall wash with different results compared to the other, relative to the other. So giving this a margin in doing this stuff will keep us on the safer side.
Got it. And basically what it does, when we mix the DI water with methanol and when we use this flashlight, so it's a bluish line. So basically, like chemistry wise, what does it does? That the bluish comes with the hydrocarbon.
That one you are referring to is actually called a Tyndall test, because the normal testing you don't have to use a torch, so you just have to compare it against a black background. Come again?
Hydrocarbon, you put the sample, you put the DI water, and then black background, you pass the flashlight, not the laser beam. So flashlight, and if it is clear like the standard solution, then there is no hydrocarbon. But if there is a slightish bluish tint in the test tube, then there is hydrocarbon.
Yeah, that's right. That's right.
All right. So
exactly,
you pass that laser beam, and then it should pass straight. So that is the different. I will not be talking about the Tyndall test.
Yeah, because when you say Tyndall test, Tyndall is actually referring to scattering of lights. So once there is some sort of turbidity present, once you combine a well-washed sample and the water, certain colloidal particles, I will just explain to you how this works. So basis of the test is that methanol is a solvent normally, having a complete solubility in water. So when a methanol wall wash sample is mixed with water, any contaminant which is soluble in methanol but insoluble in water, like oil, for instance, is forced out of the methanol and shows up as a haziness in the methanol DI water mixture. So the turbidity is actually composed of demulsified contaminants scattered evenly throughout the solution and can be seen as a bluish tinge or opaque milky turbidity. That is the principle. Yeah.
All right. So that is the principle of the haziness and turbidity when we do the hydrocarbon test using the DI water and the sample.
Yeah, and one more thing I want to add on top of this is that if you want to assess the level of your rinsing after the chemical recirculation, you can also note it by conducting a hydrocarbon analysis or water miscibility test. How is it? So in a 10 ml sample of wall wash and 90 ml of the DI water, if you notice some foaming on top of that solution after agitating, so it refers to a incomplete rinsing of the tanks. Meaning to say, during wall wash sampling, you are able to collect some residual chemicals from the bulkhead, which actually gives us an idea for an incomplete rinsing of tanks.
Perfect.
So you will not be able to detect this if you will use more sample. So more sample, you will not able to see some foamings on top of the sample. Because this detergent is more soluble in water. So if there is more sample, so there is less water. So if less sample, there's more water. So more water, tendency of the detergent is to dissolve in the water. So it will be manifested as foaming.
Got it. All right. So basically, when you are not carried your rinsing properly after the chemical recirculation, then you will see foam. And for this foam, what I understand is 10:90 is the best way to.
Yeah, much less sample. Yeah, much less sample. Much better to assess the level of rinsing being conducted inside the tanks.
Perfect. And this is the reason I got in touch with you, because all those things are never taught to us by our senior masters, and whatever you have taught me during our Ronaldo days, I am been passing it to the people who are interested.
Yeah. Perfect. Yeah, it's good to disseminate this knowledge.
Because that's how it is. If you go on board a ship, and how I was, and if you get a mate who knows his job, your life will be also easier for all the supercargos.
That's right. Otherwise, you won't be needing supercargos anymore on board.
We definitely, I am of the opinion we definitely need supercargos.
Okay.
No, it's not that. See, we will do a washing, but you get an extra set of eyes, and he is just focused only after the, certifying the tank if it is passed or failed.
adding metal bright inside the line during line steaming will actually deal with these white patches that is difficult to remove by mere steaming only.
Yeah. So next, see this in this slide, this is the zero hydrocarbon, then slide, very bad. Number 5 is very bad.
Yeah, this is what I'm saying. Normal testing for hydrocarbon, if you look at the top photo, it is just being observed against a black background. But
Background.
below it, it's a Tyndall test. So you are passing a light through the sample.
Got it. So basically what you do, see, I have been using flashlight to see if this bluish line comes or there is haziness and turbidity. And but you do this, you just put it against a black background, but without any light. You just look for this 1, 2, 3, 4, 5.
Yeah. So actually, we can't be certain in the load port what particular testing they are going to use. It's either they may use a light or they might not. So if they will just simply base it from the ASTM, normally passing a light through the sample is not being suggested. But as a industry practice, we normally use a torch to pass through a light to check for the level of turbidity. That will make our life easier, actually. So either way, we have to compare the sample against a reference sample, which is blank methanol, for instance. So at least we have a similar appearance either way.
Okay. All right. So next, I will just talk about the PPT. Will talk later. Last, inorganic chlorides. So in this chloride testing, we check for the chlorides in the tank, and the procedure is on this slide. So it says uh, you add 25 ml of the sample. Okay, and in that you add 5 drops of nitric acid 20% and 5 drops of silver nitrate 2%, or in case you have the acidified silver nitrate, that is just 1 bottle, you can add just 5 drops of acidified silver nitrate in this testing method. So in this you are just using 25 ml and 5 drops of nitric acid. So nitric acid, I remember you told me always add first. This nitric acid, we are adding it first. Why do we add it first?
Okay. Technically, if we have to base it from the chemistry level, the reason why we need to add nitric acid first over the silver nitrate is that we are trying to acidify the sample, because at a higher pH, not so acidic environment, there are some other sort of turbidity that is forming, which will give us a false positive result. So it's not really chloride. It's a different type of turbidity that can be manifested, like a silver carbonate, something like that, which is not silver chloride. Silver chloride is the formation, is the product once we add silver nitrate in a wall wash sample with chloride contamination. So we acidify first the sample, add 5 drops, and then wait for some time, and then succeedingly add 5 drops of the silver nitrate to have the chloride present react with the silver nitrate.
Okay. Perfect. So that is to be remembered. It's nitric acid first, always, and then wait, and then use the silver nitrate, because this I learned from him, and many of the previous wall wash testing in my previous companies, this was not mentioned. It was just mentioned silver nitrate and nitric acid, 5 drops each. They never mentioned to be put first. From him, and I've been following that, and I've been teaching it to the other guys as well. And for the standard solution, you just take 25 ml of the standard chloride solution, 10 ppm,
and treat it the same,
and just use it as a reference to compare. So this is the reference, how it should look for with 0, 0.2, which is the strictest that you have seen so far. for the methanol in Aljubal is the strictest, or in your experience, where is the strictest for the chloride?
The strictest for chloride is in Kuwait, Shuaiba, where they have a requirement of zero 0.2 ppm.
0.2, it's as good as this one. Oh my God.
Yeah, it's quite difficult to identify from blank to the actual sample.
So
But if you have to use some, some lights against the sample itself, you will notice some differences from the reference to the actual wall wash sample.
okay, we'll just continue. So this is under the torch. You will see this is 0.2, and then this is 1. So it looks a little bit hazy, but then if this is what your standards is showing, matching, that means you are covering up. I mean, you are ready to load your tanks. If you are
Yeah, that's right.
load requirements.
Yeah, it's a lesser turbidity than that. But I would suggest use an actual prepared solution of the standard sample, because sometimes this picture will really not give us a actual picture of what is really 1 ppm standard.
Got it.
So this is just like a representation on how to identify standards starting from lower concentration to the higher. So it's always better to prepare the actual.
Got it. So use this image for your reference, but always keep a standard solution or standard ready for comparison.
Yeah. If you have a higher concentration standard, it's always better to prepare a standard that is actually required. Like, for example, 2 ppm, you can prepare 2 ppm out of the 10 ppm standard. But you cannot prepare higher than 10 ppm, of course.
And so we are covered with the hydrocarbon and chloride. Now my favorite part, the one I hate the most, is the PTT.
Why? Why is it?
It's the laziness to start it, but once we start doing it, then it's very easy. Once your water is ready at 15 degrees and then your PTT sample is ready, so it's okay. You get the sample, keep it to 15 degree, put droplets, wait. It's fun. Yeah. But to prepare the setup, I always call my junior to come and prepare the setup. I find laziness in doing that. But anyways, in this rank, I don't care. No, it's the main job to do now.
Yeah. Yeah.
So in PTT, basically, we are checking for the impurities because the potassium permanganate is a very good, oxidizing agent. And it is purple in solution normally, but it turns into brown manganese dioxide if there is impurities in it.
Yeah, if there is impurities, oxidizable impurities present in the wall wash sample, it will react with the potassium permanganate, and the permanganate will turn into manganese dioxide, which is actually manifested as a brown or amber-like color.
So in this, I'll be sharing in my other video as well how to do the testing. But basically, I try to just talk the fundamentals by. So in this, we take the 15. How much samples we put in the test tube?
Normally, we have to use 50 ml of the sample, and then put it in an igloo cool box.
Cool box, yeah.
Prepared at 15 plus minus 1 degree Celsius. So this is the accepted standard temperature of the bath. So you have to keep it there for, let's say, around 10 to 15 minutes. Let the sample sit for around this time prior adding the potassium permanganate. So potassium permanganate, you have to add around 2 ml sample for 50 ml sample of the wall wash.
Got it. So basically here we just put 50 ml of the First you prepare an igloo box, then you put water, and then you put some ice cubes or a chilled bottle. Put a
That's how we
thermometer.
can chill it. Yeah.
Put a thermometer and then let the water temperature come to 15 degrees. That time you put all the test tubes and just mark the identity of the tanks into the igloo box and keep it for 10 minutes. Let the sample get cooled and come to a temperature of 15 degrees. Then
That's right.
you add the 2 ml of potassium permanganate solution, which is freshly prepared.
Preferably, yes.
And the solution lasts for 1 week. 1 week you can use the freshly prepared solution. After that you prepare a new one, and it's just small ampules. You just empty the entire 0.1 gram ampule into a half liter of the DI water, and then just shake it.
That's right.
Cover it with the aluminum foil and keep it in the fridge.
That's right. That's normally how we use it, or how we do it.
2 ml you drop into each of the test tubes and then close the box and check every 10 minutes.
Yeah, that's how we do it.
And the concept is the maximum duration it sticks, holds its pinkish color. That means your tank is good. That is, it is clear standards. And if the earliest into manganese dioxide, that is a brownish color, that means the tank is not good. You need to work on the tank and start re-cleaning or use some chemicals and recirculate.
That's right. That's right. Normally, it would depend what cargo is to be loaded. For instance, if you are due to load methanol, the normal specification to load methanol is to satisfy greater than 60 minutes of PFT. Other cargo like MEG or DEG, they only require greater than 30 minutes most of the time. So it would depend also which load port you are going in.
So also I have tried this, once one small experiment. I just took some small metal bright drop and I just put in the pinkish solution and it just turned white. So it reacts. So
that's another thing about PFT analysis. Once the sample is acidic, the purple permanganate is converted into colorless manganese ions.
So if you have washed your tanks with metal bright and the tanks are not rinsed properly, for sure your PTT will not be giving you the accurate results.
Chances are.
Okay, that is one thing. So we are done with hydrocarbon, chloride and PTT. Another thing for cleaning the test tubes, I remembered a very perfect practice he had given me. If you see all your books and the company manuals, it talks about, putting the hydrochloric acid, leaving it overnight. Then next day, rinse with water, DI water, methanol. But my good friend told me to use the sulfuric acid.
So it's actually an option. If you don't have hydrochloric acid, you can use a sulfuric acid. But these two acids should actually work. They should both work because manganese dioxide is a inorganic compound, and hydrochloric acid is a good acid, and it's a inorganic compound as well. It works well for inorganic compound, and sulfuric acid, on the other hand, works good on organic compounds. But it also works on this for this situation, for this occasion.
Because if you don't clean the test tubes properly after this PTT test, and then it sticks for a long time, then I've seen sulfuric acid, and
works well.
Shake the test tube, it just removes and makes the test tube brand new. But make sure you go and flush it with hot water from the galley, and then DM methanol. And also the precaution I've seen, it turns your hand black. So use gloves.
Yeah, that's one good measure always, because sulfuric acid is corrosive.
And the test tube becomes hot. Exothermic reaction, I believe.
Yeah, there is an exothermic reaction once it gets in contact with water.
Because this keeping the test tubes overnight in hydrochloric acid, no, sometimes when the vessel is in rough seas and all, so it becomes little bit difficult to do that. And the sulfuric acid
Yeah.
method is quite faster. Within 1 hour, I can
Yeah.
clean all my 24 test tubes.
Yeah. For the 24 test tube, for an hour, you are actually good. It will just take seconds before you can wash one test tube using the sulfuric acid. For the hydrochloric, it will take some time.
So sulfuric acid method is the fastest, but you have to be extra careful while using
Yeah,
that.
for both acids, you have to be careful.
So this is how the color should be, pinkish when it is a newly added potassium permanganate solution, and then slowly it will gradually change into this color. Now this color, it should take more than 60 minutes, more than 30 minutes, depending on your requirement of your next loading.
Exactly.
Many times it happens that you're after 30 minutes the color is in this range. That means you are still good enough. But if you have turned to this, that means your tanks have failed. So how tank cleaning part? Do you remember I had to scrub with the potassium permanganate? I just scrub and that got my tanks passed. That was again your
Yeah. As we have discussed, potassium permanganate is an oxidizing agent. It's a good oxidizing agent. So it's an alternative chemical for the bleach. But I'm pretty sure you don't have that luxury of having potassium permanganate on board. So yeah, it's quite expensive also. So the least you can use on board to clean most of the tanks, as there will be a very big tank that you have to clean, is to use a bleach.
bleach, yeah.
Yeah, but you have to check from time to time the quality of the bleach using a a clean colored rug to check its potency. So if it did not turn color or didn't turn white, so maybe the bleach on stock is already gone or expired.
I used this PTT that time because it was a slop tank and I had some 2 crystals extra. So I prepared a half liter of 2 bottles and then in a bucket, then scrubbed it. But again, make sure
Yeah,
to flush fresh water nicely because then it leaves the violet
stains.
stains on the
There will be
bucket
some stains.
or on the tank top.
Yeah, that's right.
So major part we have covered. So this
For the acid wash, basically you have to use 21 ml of the sample
where it is.
of the wall wash sample. One thing you have to remember is the use of a solvent. You are not using a methanol in this case. Yeah. Okay. So the type of solvents normally used are either toluene, xylene, or benzene. But as we all know, benzene is quite toxic. So we don't normally employ the use of benzene. So instead, we use xylene or toluene for wall wash. So once wall wash sample has been taken, so the analysis will actually goes as follows. So you have to take 7 ml of the sulfuric acid, add to a graduated tube, and then add 21 ml of the wall wash sample. So you will normally see 2 layers being formed. The solvent at the top and the sulfuric acid at the bottom. They don't normally mix. So after adding these two, you have to agitate it very well, like something like around 150 times. That's what they say. So it's a lot. So you will, for one sample, you will get tired shaking all these tubes. But you have to make use of a cellophane or whatever that covers the splashes out from the tube, because acid is quite corrosive, as all we know. Then after shaking sufficiently, we have to keep it under the dark area for around, say, 15 minutes, and then observe the change in color. This one. So these are the standards. So most of the time, the standard at the load port we are normally following is a scale of 2. So beyond this color, normally it already fails.
Okay. All right. As it was, I must say, 6 years, I must have done just once. I don't even remember. Very rarely this is being used. Maybe I believe
Yeah,
benzene cargo or xylene, they do this test.
yeah, yeah. It's normally the sulfuric acid part, as I've mentioned, the bottom part of that mixture that you have to check. As I've said, they don't mix.
Mhm.
So do not compare the sample at the top layer of that mixture, because that is the wall wash sample. You have to observe the change in color of the sulfuric acid,
Okay, okay. So
which
basically,
is the bottom, which is quite little
uh,
only.
so basically, what the xylene or toluene is reacting with the sulfuric acid.
Yep, yep. So any oxidizable or unsaturated impurities present in the wall wash sample that has been collected will react to the sulfuric acid. Yeah, and the sulfuric acid is the one that change in color.
Right. Next is the, we'll just do a quick for the alpha color. So platinum cobalt solution, also known as the alpha color, is just to give you the standard. Sometimes they will say the reference is less than in the ratio of 0, 5, 10, 20. So chances are that you might have the platinum cobalt solution 5, 10, 15. Then you just take a standard solution and you take your reference, your tank sample, and you just compare it matching with which of the alpha colors. So if it is matching with,
Yeah,
so you report it is less than 5. If it is matching with 10, so less than 10.
yeah. It's less if it's less than the 10 alpha standard, you can report it as less than 10, and likewise with the other standards.
So in this, there is not much. You just compare your, basically we don't,
With the standards.
tanks
Yeah,
are visually, you see that it is as clean as a methanol. That means it is less than 5.
yeah. And sometimes the vessel don't have this standard on board. So the least you can do is to compare it against the reference solvent that you are using for wall wash. Most of the time, it is methanol.
Got it. So I believe, Rex, the Zoom will stop in another few minutes. So just last, just share a little bit about spectrometer. That it's the easiest and short method of doing. So in spectrometer, you can do the hydrocarbon and the chloride, right? Two things you can do. I'm not talking about
Yep,
wavelength and all that fun, that thing that is separate, but hydrocarbon and chloride you can
yep,
check using spectrometer. I've not used
yep.
it, use it more often.
Mhm.
So basically what it does, you have a standard, you just calibrate it to the standard and then you put the sample and then measure.
Yep. Basically, the same standard that we are using the conventional way of testing the samples. It's the same standard we are testing. So, for instance, for hydrocarbon analysis or water miscibility, uh, on the conventional way of testing, we are combining uh, pure methanol instead of wall wash sample and a DI water. So that is our standard. And the same mixture we are using for calibrating the hydrocarbon analysis using the spectrometer. So the same set of samples, including the standards, are the ones being run using the spectrometer. And using the spectrometer, it will just give us a reference idea on how much hydrocarbon present. But it's not normally being used as a for reporting system. So it is used as a reference only.
Okay, okay.
Because there is no such standard that requires a reporting of a unit of FAU, or a formazine attenuation unit, which is normally the unit for reporting hydrocarbon using spectrometer.
So I believe we have covered most of the stuff. And for spectrometer, maybe someday on board, once the supercargo is actually using it, I'll just do a small recording and maybe put it on the YouTube or whatever. So
Yeah,
that will be better. If you talk about it, I think even I would also not understand unless you explain actually.
exactly. The only advantage of using the spectrometer is that it can actually monitor the progress of the cleaning. For instance, did you hear about washing water analysis? You don't have to use any methanol on it. So it's just a pure washing water. You have to take at a certain time interval. So for instance, if you are cleaning 3 hours, for 3 hours hot seawater wash, you have to take sample after 1 hour, after 2 hours, and after 3 hours. So in each, you have to run the sample using the spectrometer. So you will notice a certain graph up to what extent is the level of the contamination present. So as you proceed with the cleaning, this graph eventually will flatten. So it will flatten the curve. So once there is no significant difference with the curve, say for example from the 3rd or 4th hour, then you can tell that you may stop the cleaning already, because you have done so much. So this is the maximum cleaning you can actually reach. So this is how washing water analysis works.
Perfect. So that was.
That is,
So in this case, I see that you don't have to go down to the tank to do the wall wash.
yes, you don't have to go down.
Yeah.
You just have to collect sample every at certain time interval and check the level of contamination present.
Because basically, wall wash, you need the tanks to be dry. So that means you need to tanks
Yes,
gas free, then go down. It takes time. So it's faster, and always, it is health wise, a person going down spraying methanol, it is safe as well.
it's not good.
It's one of the
It's not
reasons
safe.
they came for this washing water analysis.
Yes, that's right. And I think they are still trying to enforce this type of monitoring and or accepting the the tank's cleanliness. But I'm not pretty sure if it's already been accepted or being considered, because nowadays they still use this wall wash, the conventional way of assessing the tanks.
So now we'll just sum it up. I would really like to thank you. Thank you for coming online. It was really nice.
My pleasure.
I was actually going to make this video by explaining the slide, but getting you on board and I mean, that's his job. He's been doing it on every ships. He's seen the worst of the ships. He's seen worst of the cleaning process, and he's met all the good mates, senior mates, worst mates. So he's in a better position to to talk about wall wash than me instead. So it was really nice to have you and get a different set of opinion. I'm really thankful to you.
Okay, no problem, Chief. My pleasure to help. Yeah, no problem. Yeah, happy to help.
All right then, thank you.
You're welcome.
Salamat.
Okay, walang anuman.
Walang anuman. All right, bye-bye.
Bye-bye.
Subscribe to Papa's channel, hit the bell icon, follow him on Instagram.
Thank you.
Thank you.